Hello and welcome to Breakthrough Flint and Feather. Right now, just Breakthrough. In this game, you play as an arrow launching itself towards the enemy's attack range in order to deal damage, while still having to avoid enemy attacks so you don't take damage yourself. It is an arcade-style game where you just keep on attacking enemies until you die and hope that you get more enemies than you did last time. Enemies spawn in random intervals between 5 and 10 seconds at a random place on the map, which makes sure that the player doesn't have a lot of downtime and is always constantly doing something, rather than just waiting for the next enemy to spawn. This game is based on a demo I created a couple years ago. I thought that basing what I am doing on a demo that I created a couple years ago will allow me to properly see how much I've improved over the time since I joined the course. And the main things I wanted to improve was player movement, enemy attacks, the enemy spawning, and the UI. When you die, the game immediately restarts, so you can keep on playing and get into the next run. And there's no form of healing in order to make sure that every bit of damage is actually seen as important and can't just be ignored by the player, because every bit of damage brings you closer to death and you can't get further from it. The game is programmed in a very simple way. I wouldn't exactly call it simple, but essentially, in the player movement, here's the variables, which is movement, look direction, move allowed, which allows, if it's allowed, then the player can move, speed, which is the speed that the player goes at, launch speed, which is the max launch speed the player can reach, and which is the launch speed that will be used later, and of course the rigid body. Now movement.x is getting the axis raw of horizontal, movement.y is vertical. This will essentially, if I pressed a W, this would be, movement.y would be 1, and if I pressed S, it would be -1, and then you just add that straight to the player, allowing it so you're essentially able to properly measure player movement without reducing a lot of efficiency. Look direction is updated to get the mouse position of course, the mouse, and it's measured in X and Y, and it makes a new vector 2 for that. Then it minuses it by the position, so it's actually accurate. Then it will do some math with it, so it will set the rotation to mathf @2 with the y and x axis of look direction times radius to degree, so it's actually a degrees measured in degrees, plus 90, so it's facing the right way. Then if move allowed is true, which is also up here, you can build up speed by holding down mouse left, and it will build it up over an amount of time because of this small number, and with a max, it has a max of 2000, then we'll start the coroutine of check launch, and if you let go early and have a less big move speed, it will still start the coroutine again, so you could let go of it early and just not go as far. Then it sets, in check launch, it sets the drag to 5, because this made it feel a lot more natural to launch the player character. It adds the force in the upward direction times the launch speed, then it will reset the launch speed to 0, then it will wait until the magnitude is above 2, and stop the player from moving at all, and then wait until it's below 2 and allow movement again, and set the drag to what it is normally when you're just moving around. The enemy controller works fairly simply. It look direction, it gets a player, which you have to actually set the player here and find the game object of player, because when you are instantiating an object using a prefab, you can't actually have a game object set into the prefab, so you need to find it when you start the thing, otherwise it will just have no game object and it wouldn't work. Then this is essentially doing the same thing that we did in the player movement with the mouse position, but instead for the player position. And of course it does all the same stuff, plus 90, so it places the right way, and then it transforms in that direction upwards across an amount of time, so it's constantly moving towards the player. Then when you have when you trigger and get on trigger enter with the player, if the movement allowed is equal to true, then you actually collide with the player, not something else, then move allowed is false, and you start the coroutine of attack. And the coroutine of attack essentially only starts the coroutine of something else in the sword controller. It was initially meant to be its own thing, but I was able to put it all in sword controller, which I thought was just a bit better to have it all in one place for the attacks. Then if the collider get component parent, now the reason it's parent and not the player itself is because I had to have it so the player collided with the walls and the boundaries of the camera without colliding with the enemy character while still being able to detect triggers. So I gave the player a component that will go hit walls and has a different layer to the collision of the enemy, so it still goes through enemies but it hits walls. And then I gave the player a child that had a different layer of collision that was a trigger, so it kept on following it, and could trigger this, but it just means that I needed to change everything to in parent. And then it will get that, and then if it's moving at a magnitude above 20, then this is to make sure that the player can't just walk into the enemy and do damage. Then it will set the health to the health minus 0.25 float. The reason I have to set a temporary variable here is because you can't do it directly with local scale. So you would need to set a temporary variable, modify the temporary variable, and then set local scale to that temporary variable. Then if the local scale of the x-axis of the health bar is 0 or below, then it will destroy the game object. And then it's the coroutine attack, of course, starts it in the sword controller. Now the sword controller has a pivot point, which is the knight, which it rotates around when it's attacking. It has its own renderer. It has the angle per second, which is how fast it rotates. It has its own collider. It has the health handler, which is the script of the health bar in the UI. It has its own rigid body. It has how much it has rotated so far, and if it has damaged the enemy so far. I needed to do the same GameObject.find for the health for the sword, but instead get a component health handler in their GameObject.find. Then it's a public coroutine of rotate, which is the attack. It will set the collider and renderer to enabled. Wait 0.2 seconds to give the player a little time to react to a attack. Start measuring the rotate, how much it has rotated, and while that's below 180, it will do some maths, times the angle per second by the time, and then do math with 180 minus how much it's rotated so far, then rotate around that using that step that we just created as the minus that you will start with the rotation. Then it will keep on track how much we have rotated until it hits 180, and it will then set the collider and renderer to false, and then reset the position so it doesn't just rotate around the enemy again when you next attack. Get component parent enemy controller and allow them to move again, and if it and set has damage to false. Now this is where it damages the player if you've collided with the player. If has damage is false, then it can do it, but it sets has damage to true, so it doesn't hit the player twice in one attack. And then it reduces the health, which is why it causes the health here. Then there's the enemy handler, which spawns enemies between a range of 5 to 10 seconds, and will return a range between 5 to 10 seconds if spawning equals false. It will, and then it spawns equals true, so it doesn't do this every frame. It will wait for that 5 to 10 seconds and then instantiate a new enemy and set spawning to false, so it starts again. Health handler sets the health to itself, and if it reaches 0, then it will reload the scene. And slider controller will wait for an input on get mouse button down and show you how much you've charged up your slide, because it goes at the same rate as player movements charge up, and it has a max of 2000. Then if get mouse button up, slide value equals 0, and if move allowed equals false, slide value equals 0, so it doesn't keep on building up over and over again. If I could extend on this game, I would add different enemy types. The things that went well were essentially making my game again in new code, and just, you know, a new shine of paint so that it's a lot more polished and a lot better than it used to be. Things that were tough were some of the bugs that I encountered took quite a while to actually fix. For example, the one where I have to find the game object or find player took me until near the final day to fix that, because I was working on other things and I just couldn't fix that at that point until I needed to.